Hello friends, welcome to Shiksharthi. In this video, we'll be discussing linear arrangements under the head of permutation combination. So let's start. So if you recall, in my first video, I had talked about these 6 points in which not only had we discussed what is the difference between permutations and combinations, but also we had discussed various types of permutations and combinations. So in this video, we will be focusing on linear arrangements. So as the name itself signifies, line. So the line may be a straight line or a slightly a distorted line, but the point to understand here is, if I have two people, let us say there are two people A and B, such that they are supposed to stand in a line, in how many ways can they do it? So as discussed earlier, there are two ways of approaching a question. One is the logical way and the second is the mathematical way. So if I have to approach this question in the logical way, that is maybe without the use of mathematics or with some ingredients of mathematics, we'll be basically talking about the fundamental principle of counting. So what is the fundamental principle of counting? We can write down all the possible cases if it can be scaled down. I mean, if I have a greater question also, I can always scale it down so that it becomes manageable. But in this case, it is already manageable. So if I have to make two people stand in a line, this line can be horizontal or it can be vertical or can be at any angle. But the point here is standing in a line. So two people can stand in how many ways? One is A stands first followed by B. Second is B stands first followed by A. So how many cases have I written? There are two ways in which this can be done. Similarly, if there are three people, let us say there are three people, the same question can be given in a different question format. So you will see that basically the concept remains the same, but the same question can be given in a different format. So if I say there are three seats available, and only one person is allowed to sit on each. Only one person can occupy a seat, a single seat. And there are three people A, B, C. In how many ways can they sit down? So let us start it off. So first of all, we'll be discussing all these three cases, all these three questions to be precise here, with the help of fundamental principle of counting, which is more on the logical side of it or the analytical side of it, wherein you are trying to make cases. So how will we do it? Just for the sake of reasoning, I'll say that this is the first seat, this is the second seat, this is the third seat. Right? So now A can sit in the first place in how many ways? This is just like fixing A. So when I fix A in the very first place, the question boils down to this question only, the first question only, which I had presented. In how many ways can two people be arranged in a linear arrangement? So if I make A sit here in the first place, these are two cases that I can make. Similarly, I can make B also sit down in the first place. In that case, the remaining places can be occupied by both A and C. And the third case here is C sits in the very first place. Okay. Followed by A, followed by B, or followed by B, followed by A. Now, all these cases are mutually exclusive to each other. Now, when the cases are mutually exclusive to each other, what is the mathematical operator that we use? We use addition. And when the cases are independent, which is the mathematical operator that we use multiplication. What do you mean by mutually exclusive? Mutually exclusive means that, I mean, if I talk about there are two cases which are mutually exclusive to each other, it means that both of them cannot happen simultaneously. I mean, both the events that you're talking about cannot happen simultaneously. Right? Now, when we talk about independent cases, in that case, we can talk about two or more events happening at the same time without affecting the functioning of one another or each other. Right? Okay. So now in this case, if I am doing it by the way of fundamental principle of counting, what am I supposed to understand here? I am supposed to understand that all these 6 cases that I have written, all of these 6 cases are mutually exclusive. So this is first case, second case, third case, fourth case, fifth case, and the sixth case. You add all of them and then you are able to say how many cases? There are 6 ways. Another maturer approach for this question now. So if I talk about a maturer approach, I can say, I can use the same logic here. This is the first place, second place, third place, right? And how many people are there? In total, there are 3 people. So the number that I'm writing inside a circle, I'm basically talking about what is the total count of people, those who can sit in a particular place. Okay. Now, so the first place is open to all these 3 people, right? The second place, now naturally when the question says that only one person is allowed to occupy a particular place, in that case, now the second place is open to how many people? You subtract one case from here, because there is one fellow. I mean, this one fellow could be either an A or a B or a C, who has already occupied the first place. So I subtract the one possibility from the second, I mean, who can sit in the second place. So how many total number of cases, total number of possibilities? There are 2 people now, those who can sit in the second place, followed by, now here I'll subtract a 2, because one person is already occupying this place, one person is already occupying this place. So the total number of people, those who can apply, I mean, those who can sit on the third seat are 3 minus 2. So you have only one possibility. And now you will say that all these 3 seats are just like independent seats. These are independent events, because the question says that every seat or each seat is supposed to be occupied by only one individual, right? So it is just like if I occupy the first place, I will not be sitting in the second place, so without affecting the happening of the second event. So what is the mathematical operator that I use here? I can use multiplication. So in total I get 6 cases. A further maturer approach, I mean, so this was the first way of doing it, which is the basic way, logical or the analytical way. Second way is you are using the concept of independent events, right? Third is, now I know that 3 people can occupy 3 places in how many ways? 3p3, which is just like saying 3 factorial divided by 3 minus 3 factorial. So which is just like saying 6 ways. I hope you have understood this. Now we'll be talking about the fourth case. I mean the third question, to be precise. So let us say there are 4 people, A, B, C, D, and they are supposed to occupy 4 places. So as of now, you would see that I am taking a question wherein as many people, those many places. But you can even have a case like you have only 2 seats or you have only 3 seats and the number of people to occupy those seats are on the greater side. Okay, so applying the maturer approach here, though I can use this approach also. So applying the maturer approach here, the first place can be occupied by any 4 of them. Now one place is already filled up, so and the total number of people available are 4 each in every place. So now in the second place, I'll subtract 1. Now there will be only 3 people available for the second place. For the third place, for the third seat, there will be only 2 people available, and for the fourth seat, there will be only 1 person available. So what are the total number of ways in which 4 people can sit on 4 different seats? So mark the words being used here. Here 4 people are different in any case. Even if they are twins, they'll be considered as different people only. And the seats are different, and the condition is that only 1 person is supposed to occupy a seat. So how many ways in total? 24 ways. Now, taking this discussion forward, you would see that many a time you get questions like, how many 3-digit numbers can be formed? The moment we say how many 3-digit numbers can be formed, we can use the same principle as we had used in question number 2. But the point to be now understood further is, under the head of linear arrangements, I can talk about similar, I can talk about dissimilar objects. So here in all these 3 questions that we had discussed earlier, we were talking about linear, dissimilar, right, and unbiased. What is unbiased? As we had discussed last time also in the earlier video, unbiased is an event. An event is supposed to be called as an unbiased event only when there is no precondition. If there is a condition involved, what could be the condition? There are 3 people supposed to sit on 3 different seats, given that every seat is supposed to be occupied by a single person, such that A always occupies the first place. In how many ways can this be done? So if A occupies the very first place, that means there are only 2 places left which can be filled in 2 factorial ways. Now this comes as a question on linear, dissimilar and biased. But as of now, I mean, all the 3 questions that I had talked about were basically linear, dissimilar objects and unbiased events. And then independent and exclusive events is just like an operator to get to the correct answer. I hope you would have understood this. Okay, so coming back, this is the last example that we are taking here. If somebody asks me a question, how many 3-digit decimal numbers can be formed? Now, when I am talking about decimal numbers, please do not get confused, like I am not talking about non-integers. I am talking about natural numbers. So, how many 3-digit decimal natural numbers exist or can be formed? So, this you can understand with the help of hundreds place, tens place and ones place. Now, I know that hundreds place can be filled by any decimal digit like 1 to 9. So, how many possibilities, how many people can sit in this place? How many digits can sit in the hundreds place? 9 digits. How many digits can sit in the tens place, or the tens place can be occupied by how many digits? 0 to 9, which is just like saying 10. And how many digits can sit here? 10. So what are the total number of cases here? 900 numbers. This was the first question. So the question was, how many 3-digit numbers that can be formed, or how many 3-digit decimal natural numbers exist? The answer is this. So this falls under which category? It is a linear arrangement. We are talking about, are we talking about dissimilar objects or are we talking about similar objects? We are talking about both. How? Because all these numbers that you have written, you would have come across a number like 100 in which 2 objects were the same. You would have even come across a number like 123 in which all the 3 objects were different. So this is a perfect example of a linear, similar and dissimilar both. So what is an unbiased event? An unbiased event by definition would be similar plus dissimilar both. What is a biased event? It will be either similar only or dissimilar only. That is a biased event. But an unbiased event would be a combination of both. Right? Okay. Second, taking this question forward, there are so many questions that can be made here. So now if I want, so this is an unbiased event, linear, unbiased, independent is what we are using to get to the answer. Okay. Now if the condition is, how many 3-digit numbers can be formed such that all the digits are dissimilar? There's another way of putting up the question, no 2 digits are the same. So let us understand it like this now. So in the hundreds place, I can have all 9 of them. Now the fellow who sits in the hundreds place now cannot sit here because repetition is not allowed. So dissimilar is just like saying repetition is not allowed. So you subtract 1 possibility from here. So you are left with 9 possibilities. And then the 2 objects or 2 digits that you have used in the first 2 places cannot be, that object cannot be used in the ones place, which is the digit cannot be used. So subtracting 2 from here. So you get 8 possibilities. What are the total number? 648. Now if I subtract this, I get something like, I get 252 numbers in which at least 2 places would have had. Now this is just like saying, if from 900, if I subtract 648, I get the case for, so this is 900, right? Dissimilar is just like saying 648, and similar object you get how much? 252. Now when you are saying similar, there are 252 numbers in which 2 places, at least 2 places will have the same digits, right? And this in 3 digits itself, talking about the 4th question, which is the last discussion that we are going to have here, there are different type of questions that they can give to you. A different kind of a question here would be, how many 3-digit numbers have a 0 in them? Mark the words being used, have a 0 in them. Now we know that the 0 cannot come in the hundreds place because hundreds place is 1 to 9 digits, tens place is 0 to 9 and ones place is again a 0 to 9. These are the digits that you can use in these three places. Now the question is, how many 3-digit numbers have a 0? Now we know that we need to take two exclusive cases. Which is the first case? Now if had the 10th digit been a 0, how many numbers can be found? And if the units digit would have been a 0, in that case how many numbers can be found? Okay, now if 10th digit is a 0, I know that the first place the total number of cases here are, and here are 10. So here this question will be treated as an unbiased question. Will it be treated as an unbiased question? No, not at all. Why? Because it is already coming with a condition now. But once the condition has been decided, now when you move on to the next stage, you will consider it as an unbiased event, right? To get to the final answer. Now what is the final answer here? The hundreds place, there are 9 different digits, and the units place, now these you already have a 0 here, so you have to subtract one case from here. So how many cases do you get from here? 81. And the same thing you will say for, had I had a 0 in the units place, I would have had 9 possibilities here, and I have already used a 0, and the question says how many 3-digit numbers have a 0. That means if I have a 0 here, I can't have a 0 here. And how many total possibilities can I have in the 10th place? I can have 10 possibilities in the 10th place. I can use 10 different digits, but excluding a 0. So in that case, I'll be having what? 9 into 9, which is 81, and these are two mutually exclusive events. What do we do for two mutually exclusive events? We add them, and once you would have added them, you would get a final answer like 162. Now please keep in mind that the answer that you have got here, which is 162, only talks about those 3-digit numbers which have a 0 in them. Had they asked you how many 2-digit numbers have exactly 2 zeros in them, in that case you would have dealt with the question separately. So this is just like saying fixing the tens place by a 0, fixing the units which is the ones place by a 0. In that case, the hundreds place can be fixed in how many ways? How many possibilities? 9 possibilities. So in that case, the answer would have been the 9. Right? But the question here was, how many 3-digit numbers have a 0 in them? If you feel that something knowledgeable has been discussed today, please do not forget to give us a thumbs up. Please do not forget to subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some special videos and some special topics, please put it in the comment section. Thank you so much. Until next we meet, goodbye.